Hello dear learners, welcome in the part 4 of precipitation titration. Today we will see the Mohr's method for precipitation titration. So as the symbol indicate, at the end of this reaction you will get the red-orange precipitate. We can say the reddish precipitate from yellow. So he was the scientist from where we got the method. It's a Mohr's method. So this is known as Mohr's method because of the name of the scientist Carl Friedrich Mohr. What is Mohr's method? So here the titration of NaCl, we have to fill the NaCl in a conical flask with silver nitrate. So in burette there will be a silver nitrate using the C, which indicator we have to use in this method. So potassium chromate is an indicator that we have to use. As we have seen in the Fajan's method, there was a adsorption indicator. In Volhart's method, there was a ferric indicator. Now here we have to use the indicator. It's a potassium chromate for the same reaction, but there will be a different indicator. So these methods are differentiated on the basis of the indicator firstly. So what is the end point here? So formation of a colored soluble precipitate. It will be from yellow to orange color. Let us consider, now see, just imagine the titration of 0.1 molar NaCl with the 0.1 molar silver nitrate by using this indicator. So this is the Ksp value of precipitate, that is AgCl and Ag2CrO4. So what happened? At the end of the titration, we will get two precipitates. Firstly, the AgCl will get precipitated. After that, the excess of silver will react with the chromate and we will get the precipitate of silver dichromate. So here we can say this is the Ksp value of AgCl and Ksp value of silver chromate. Now see what happened here. So as we are adding the silver nitrate, there will be a precipitation of silver chloride. So at the first point, the red silver chromate is just precipitated. We shall both the salt in equilibrium, in solution. So we can write like this, the Ksp of AgCl. If we want to find, actually it will be here, right? So if we want to find the solubility product of silver, or we can say the concentration of silver, then we can go for this. So there will be this reaction and we can write this for chromate also. It will be similar for chromate and chloride. So we can write this reaction and we will get this equation 1. This value as a equation 1 for silver. Now the equivalence point, as we have already seen, at the equivalence point there will be no excess of silver or no excess of chloride because it is both are equivalent. Both are equivalent. It should be present. So it is our end point of the titration. We will get the reddish colored precipitate. So we can write the Ksp value of AgCl is equal to the solubility product of Ag plus and Cl minus. So both are equivalent. Ag is equivalent to Cl, that we can write. So here we can consider this Cl is equivalent to Ag. So we can write this. So this is the value for chloride. Now from equation 1 we can write this because both are in a equilibrium. We are getting both the precipitate, but first we will get the AgCl precipitate. After that we will get the silver chromate precipitate. So for chromate we can write this value. Whatever we are getting over here in the first reaction, first equation. Whatever we are getting over here in the first equation. So this is the value for chromate. So here, this is how we can find the concentration of indicator. It should be 0.0014 molar. So this method we can use, what are the important points here? We can use this method for determination of bromides. For this method we should maintain the basic pH, that is 6.5 to 9. Here we have to maintain the basic pH. Okay, so only neutral of slightly alkaline solution we have to use. In acidic solution, what happen? So if there is an acidic solution, this chromate will react with acid and there will be a formation of chromic acid. So we don't want it. Okay, we don't want it. That's why there will be no acidic condition. Now see, one thing should take care about this method, that we know that chromic acid is a weak acid. Okay, so chromate ion concentration is reduced and the solubility product of this silver chromate, okay, it may not be exceed. So it is a simple method. Okay, we can use, what we have to do is we can make the solution neutral. Okay, and we can add it in a excess. So calcium carbonate we can use, or we can use either calcium carbonate to make it neutral, or we can use the sodium hydrogen carbonate. So alkaline solution, or if it is more alkaline, then we can make it acidic by using acidic acid. So we have to maintain ultimately finally the neutral to alkaline solution. This is a very important thing that we should take care about. Now this is just for your information how we can prepare 0.1 molar silver nitrate. So for that we have to weigh as per the molecular weight. We have to weigh this much product and we have to dissolve it into the distilled water. Now this is the preparation of how we will standardize the silver nitrate. So for that we have to take 0.1 gram of NaCl. Then we have to add a distilled water, acetic acid, then eosine solution and methanol. Then we can titrate it against silver nitrate. So we will, in the presence of this, and we will get AgCl as a precipitate. Now see, potassium chromate indicator. So this is a preparation from IP how we can prepare the potassium chromate indicator. So here we have to weigh the 5 gram of potassium chromate. We have to use distilled water, and from this we can add 1 ml of solution as an indicator for this much amount of titrant we titrated. So thank you dear learners for watching the video.